Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. My name is Andina Putri from Semarang State University. Today, I will present the result of our team research with the title is Analysis of UNNES Embung Floor Capacity. Our research background is the first in 2010, Semarang State University built a reservoir with an area of 900 meters square and a depth of 3 meters. The embung construction was carried out to the east of the Language and Art Faculty. This is based on the results of the analysis that this area is the lowest point on the west campus of UNNES, so that the waterways from the Central Library, Auditorium, Faculty of Mathematics and Natural Science, the Rectorate, and the Faculty of Language and Art can be directly streamed to the reservoir. In the development of the embung on the UNNES campus, currently there is a lack of maintenance at the reservoir. This can be seen by the condition of the reservoir water, which is increasing cloudy and smelly, and the amount of inorganic waste floating on the surface of the reservoir water. There are several factors that can cause change in the condition of the reservoir, including change in land use, change in the campus environment, so that the ability to absorb water into the soil is reduced, so that the runoff when it rains is getting bigger, and because at this time the UNNES campus has become the center of economic activity in addition to the education center on Mount Pati. From this background, the problem occur can be formulated is the capacity of the reservoir capacity is due to change in land use change around the UNNES campus, and the purpose research is analyzing the carrying capacity of the reservoir against change in land use change around the UNNES campus. Our research method is the research method used is the flood hydrograph routing method in the reservoir using the stormwater management model program to obtain the maximum capacity of the reservoir flow discharge, after which a comparison of the planned flood discharge of the embung to the flood discharge in the existing condition of the reservoir is carried out to assess the capacity of the UNNES reservoir against land use change. This picture is a catchment area Embung UNNES. This picture shows the area or catchment area of Embung UNNES is mostly on the west side of the UNNES campus. This table shows that amount of rainfall for the observation period 2001 until 2015 from the Sigote Sumur Gap Range Station, which is used as data for determining the frequency of rainfall in the Embung UNNES catchment area. From the analysis of the frequency of rainfall using the Kolmogorov-Smirnov test model, it was found that the appropriate rainfall distribution was the Gumbel distribution method. The result of the rainfall analysis will be used as data for determining the amount of flood discharge at the UNNES dam. This is a table for the previous and imprevious area in the subcatchment area of Embung UNNES condition during planning in 2009. This picture is cut lengthen Embung UNNES when planning. UNNES Embung data during planning is depth of Embung flood 4 meters. Depth of Embung for effective is 3 meters. Embung area for flood is 3,612 meters square, and Embung area for effective is 3,379 meters square. And this picture is cross-section of Embung UNNES existing condition. The calculation of the flood discharge is calculated using the stormwater management model program. From the result of the flood hydrograph routing using the ICMM program, the results show that the inflow when flooded to the UNNES EMBUNG is 3.52 meter cubic per second, and the outflow can be flowed at the 2.22 meter cubic per second, with a water depth in this condition peak or flood is 2.20 meters. With a flow discharge magnitude of 3.52 meter cubic per second, with a 10 years rain return period of at the UNNES reservoir, there has been no flood or water runoff that exceed the cross-sectional surface of the reservoir. From this, it can be seen that the current condition of the UNNES EMBUNG still able to accommodate flooding around the UNNES campus area. From the result of surface and field investigation, there are still puddles at the certain location point when it rains. This is apparently caused by the following. The first, a geometric cross-section of roads in the UNNES environment that does not meet technical principle in road planning. There are several points of the road that are in the shape of a basin. So, there is the potential for inundation when it rains. The second, the drainage channel is one of the main components in channeling runoff water when it rains. In fact, in the field, the slope of the existing channel is not sufficient to drain water, so that at certain point there is water flow that cannot enter the reservoir. And the third, the operation and maintenance of drainage channels in the UNNES campus environment is less than optimal. This can be seen from the amount of sediment or sediment in the drain channels, so these can reduce the capacity of the channel. And the fourth, the cross-sectional dimension of the drain channel are too minimal, and the routing of the drain channel that enter the reservoir need to be improved to accommodate the development of building construction around the UNNES campus. There is a need for further studies on the dimension and routing of drain channels. That's our presentation. Thank you and keep physical distancing.